Okay, section 2.4, slope-intercept form. Slope-intercept form is something that I think that you've seen before in Algebra 1. Okay, I'm just going to review what it looks like here real quickly, and then we'll take a look at how to take some given information and write an equation in slope-intercept form. Okay, slope-intercept form is when your equation is solved for y. The coefficient in front of the x, which is where the m is here, that's considered the slope. And the constant, which is the b here, that is the y-intercept. Okay, so our goal on all of these problems here today is going to be to take the information they give us, whether it's a graph or just some other pieces of information, and write the equation in slope-intercept form. So we're going to start with example 1. Here you can see they give us a graph of a line. They're specifically identifying 2 points on this line right here. And so what we're first going to do is I'm going to go ahead and notice that the y-intercept for this line is at -2. Okay, it's crossing the y-axis at -2. Okay, so if the goal is to write the equation in y equals mx plus b, I know right now that I could go ahead and substitute a -2 in for the b. Okay, now to get the slope, the m, you could do one of two things. You could take the 2 points that you're given, substitute those coordinates into our slope formula, y2 minus y1 over x2 minus x1, and that will give you what the m should be in the equation. The other option, and I'm fine with you doing this, you just have to be a little bit careful. You could count the slope, okay? If you can identify those 2 points and start with the lower of the two, you would want to count how many units are you rising and then how many units are you running to get to that second point, okay? Because we know that slope is rise over run. Okay, now here's the one thing you have to watch for with this. If we were to do that, we would rise up 1, looks like we're running to the left 4. The slope of this line, though, is not actually 1/4. Okay, the slope of this line is technically -1/4. Okay, it is -1/4. And so if you're going to use the process of counting up and over, the burden lies on you to look at how that line is leaning and know that, okay, this is leaning as a negative sloped line, and so you have to then make it negative. The advantage of just using the 2 coordinates and using the slope formula is if the slope is supposed to be negative, it will just come out negative anyhow, okay? So I have no preference. You do not have to show the steps for this on a problem like this. You could count it, okay? All right, let's look at example B. Okay, again, same directions. The goal here is to write the equation in slope-intercept form. Okay, in this example, they give us the slope, so there's our m, and then they give us a point, 0, 4. Okay, so I'm going to go ahead and plug the slope in for the m, okay, but we need to know the y-intercept. Now, I want you to think about what all y-intercepts have in common. Any point that is on the y-axis, what it would have in common is it would have a 0 as the x-coordinate. Now, this is just a coincidence, but if you look closely, you'll notice that the point they gave us had a 0 in the x-coordinate. So they actually gave us the y-intercept with this point, okay? So we would take that 4, and we would substitute that 4 in for the b, and that's the y-intercept, okay? I will tell you, had this x value here been anything other than a 0, we would not have been allowed to grab that y-coordinate and just shove it right in here for the b. This has to be a 0. Okay, so we're going to tackle today situations where maybe the point they're giving you is not actually the y-intercept and how we could still come up with a way to put the equation in slope-intercept form. Okay, so let's go ahead and look at example C. Okay, example C now is giving us 2 coordinates, and they want us, again, the directions are to write the equation in slope-intercept form. Okay, so I'm going to start with the slope. We know from the previous section that if you're given 2 points to get the slope, we would do y2 minus y1 over x2 minus x1. Again, the order you subtract the y coordinates does not matter as long as you subtract the x coordinates in the exact same order. Looks like we would get 16 over -4. Our slope would be -4. Okay, so I'm going to come back over here, plug -4 in for the x, and I need to come up with the y-intercept. Now again, look closely at these points they gave you. One of the points they gave you has a 0 as the x coordinate. That means the corresponding y-coordinate of -6 would then be the y-intercept. Okay, now we're just getting lucky here with these because in the previous example here and in this one, they kind of handed you the y-intercept right off the bat. Okay, now we're going to look at some examples of some problems where they're not going to give you the y-intercept, and this is where using something called point slope form is helpful. Okay, when you have point slope form, you're going to obviously plug the slope in for the m, but the reason this is called point slope form is you're going to plug in the coordinates of one point in for the x1 and the y1. Okay, I did the first example for you, but let's go ahead and jump in with example B. Oftentimes, it is best to use point slope form when the information that you're given is just that, a point and the slope. Okay. Now I know there's probably a different way to go about doing these problems as well, but you are in an honors class. You need to be comfortable using point slope form, and so I would like for you to use point slope form for these problems. Okay. So I'm just going to write down generically point slope form here first, okay, and then underneath we'll make our necessary substitutions. So they tell us in this problem that the slope is 1/2, so I'm going to plug that in underneath the m. Okay, and then you want to be careful here. Make sure that you're plugging the correct coordinate in for the correct spot. y1 should be substituted out for a 3, and x1 should be substituted out for a 2. Okay, I should draw your attention to the fact that in the formula, these are subtraction signs here and here. So that's why even though this point was a +2, +3, when they were placed into the formula, the subtraction sign is in front. Now, had these coordinates been negative, then we would have had a double negative situation and it would have made this positive. Okay. Now, the goal is to still write the equation in point slope form. Anytime a problem says write an equation of a line, the assumption is we want the final answer solved for y. Okay, so what you're going to do next is you're just going to solve the equation for y. Distribute 1/2. Okay, so 1/2 distributed to 2 is going to be 1. And then you're going to add the 3 to the other side. And we end up getting y equals 1/2 x plus 2. Okay, that would be the equation in slope-intercept form. Let's try one more here. Okay, here we are given 2 points. This time they are negative. Okay, if we're going to use point slope form, okay, point slope form, we're going to plug the slope of -3 is going to go in for the m. Okay, here's where I'm going to get some double negatives happening here. -1 goes in for y1, and then -2 goes in for x1, and that creates these double negatives, which I'm going to connect and make these positive. Okay, so I've got y plus 1 equals, I'm going to go ahead and distribute this -3, and then I'm going to subtract the 1, and I get the answer y equals -3x minus 7. Okay. All right, I went ahead and did the next example for you. It's basically the same type of problem as the two we just did, only it was multiple choice. And so once you kind of work it out, at least even just I went as far as getting the slope. And since all of these potential answers had different slopes, I automatically knew which answer to circle. Okay. All right, so we're just going to take a look at the back with parallel and perpendicular lines here. Again, hopefully a concept that you're somewhat familiar with. Here's the key that you want to make sure that you're comfortable with. With parallel lines have the exact same slope, whereas perpendicular lines have slopes that are opposite reciprocals. Okay, so for example, if I tell you the slope of one line is -8, then the slope of a line that would be perpendicular to that would have to be the reciprocal, but also the sign would have to change. It has to be the opposite and the reciprocal, so then it would have to be positive 1/8. Okay, so we're going to work through these three problems here quickly, keeping in mind parallel lines have the same slope, perpendicular lines have slopes that are opposite reciprocals. Okay, the goal here is to come up with an equation in slope-intercept form. It has to go through the point 5, -6. I'm going to go ahead and circle this word. It has to be perpendicular to this line here, okay? Now, the reason they're telling you it has to be perpendicular to that line is because they want you to grab the slope of this line and make a change to it, okay? If the slope of this line is -3/2, then the slope that we should be using for a line perpendicular to that should be the reciprocal, and we should flip the opposite sign so that it is now positive 2/3, okay? And then with that, we're going to use the point they give us and our new slope that we have adjusted so that it's perpendicular, and we're going to get used to point slope form here. Okay, very similar to what we had done on the previous examples. Okay, you can see you're going to get another double negative situation right here in front of that 6. Okay, we're going to distribute a 2/3. That's going to make this 2/3 x minus 10/3. Okay, and then we will subtract 6 from both sides. Okay, now I don't have a calculator that I can pull up here on this video, but hopefully you guys are all comfortable doing this on your calculator. Okay, what you're going to do on your calculator is you're going to type in -10/3 minus 6. Okay, and you're going to see a decimal there. I do not want you to write the decimal. You need to switch that decimal into a fraction by pressing the math button and then choosing option 1 for fraction. Okay, and it'll switch that decimal into a fraction, should show you -28/3. That is what you need to write down as the y-intercept. Okay, let's try another one here. Write an equation of a line. Again, we're doing slope-intercept form that passes through the point 3, 7, only this time it will be parallel to this line here, okay? So we are, again, interested in the slope, and you got to ask yourself, if it's going to be parallel to this line, do I need to make a change to the slope? Well, we set up above here, parallel lines, they have the same slope. So I'm not going to make a change to this slope at all. I'm going to keep 3/4 as my slope. I'm going to go to point slope form. I'm going to go ahead and substitute my slope in for the m, and then I'm going to use my point here, 3, 7. You got to be careful. Make sure you're plugging the x coordinate in for x1 and the y coordinate in for y1, and then we are solving this equation for y by distributing the 3/4 to the x minus 3. Okay. Finally, I'm going to add 7 to both sides. Again, I would encourage you on the calculator to type in -9/4 plus 7. You will see a decimal, and then hit that math fraction button, and it will switch that back into a fraction. Should be the fraction 19/4. Okay, finally, in example 6, writing an equation, slope-intercept form, going through this point. Now we're back to perpendicular to this line right here, okay? So we want to say, all right, what's the slope of this line? Now, if your slope does not look like a fraction, you can make any number look like a fraction by simply putting it over 1, okay? Now remember up above here, we said, how do the slopes relate of perpendicular lines? They are opposite reciprocals. So if the slope of this line is -5, then I need our slope to be positive 1/5. Okay, that's the slope that we are going to use for our line that will be perpendicular. And then we're going to plug in 3 for x1, and here's another double negative situation here, -2 for y1. Okay? All right, we're going to distribute the 1/5, and then again, using that math fraction button on the calculator here, you're going to type in -3/5 minus 2 and switch it, switch it back into a fraction. You're going to get -13/5 as the y-intercept. Okay. Your homework assignment for this lesson is worksheet 2.4.